the constellation of which our solar system is one small part. Ranking third in that system, the planet Earth is blessed with life. The source of that life is water. Rivers crisscross the planet, saving the world from a dusty death. Water is essential to every living thing, including man. Hardly surprising that it was around this priceless commodity that he began to gather, and in doing so gave rise to what we call civilizations. The pyramids of Egypt represent one such civilization. They are the only surviving structures to be numbered among the 7 wonders of the world. The wonder is that for 4,500 years they've kept their silent vigil, monuments to the earthly powers that built them. The wonder is that they were built at all. The Great Pyramid, 230 meters long at the base and 146 meters high, consists of an estimated 2.7 million stones. Built for the pharaoh Khufu, sometimes known by his Greek name Cheops, the Great Pyramid was originally covered in highly polished white stones. Little wonder this pyramid has been an inspiration to poets and mystics alike for centuries. You stand at the foot of it and realize just how small you are. The concept and the structure both too overwhelming. And the questions start to form in your mind. How were the stones quarried and transported? How were they lifted into place? How long did it take to build a pyramid like this? Above all, why build it in the first place? You try to take a photograph from up close, as if somehow to contain the pyramid within known comfortable limits, and find to your dismay that it's impossible. Yet from a nearby hill you look down on the Giza complex and find it easier to comprehend, the magnitude reduced by distance to more manageable proportions. At ease now, you find the scene fits neatly in the lens. But no amount of photographs can ever explain the mystery that is associated with the pyramids. For centuries, men have been drawn to Egypt as much by its promise as by a sense of history. In 1977, in a bold attempt to come to terms with the enigma, NTV built a pyramid of its own in the Giza to probe the unknown and to test accepted knowledge. The pyramids were the tombs of kings who rode the sun's rays to eternal life. But what of the mortals who built them? Exactly when and how did they arrive at the particular shape and form that men find so intriguing? And what can we learn from them today? The answers may well lie here, 100 kilometers south of Giza. In this bleak desert are the ruins of another pyramid, less visited, less photographed than its illustrious fellows. It's virtually forgotten. Yet in the ruins of the so-called false pyramid of Meidum lie clues to some of the mysteries surrounding the Great Pyramid. This is where our search for answers will begin. Evidence suggests the banks of the Nile were settled as long as 6,000 years ago, despite the odds. The scorching sun, the encroaching desert, the floods. Forces of nature against which man stood alone and defenseless. But together, men found a way of fighting back. In cooperation, they found a way of dealing a challenge to nature. Joining with others, man learned to control the waters of the Nile. He measured the lands that contained it. He cultivated crops, set up villages. His challenge succeeded because it was unified, thanks to the authority of a force as powerful and as unquestionable as the Nile itself. Out of that challenge, the ancient Egyptian empire was born. The authority that made it possible was the pharaoh. His rule was absolute, and by uniting under it, the people learned to control their environment, to use whatever nature dealt them. The first indication of the Egyptians' awareness of stone as a material for building comes in the 3rd dynasty with the step pyramid of Zoser. Millions of stones stacked together to a height of 60 meters. Modest by any standard, but at the time it must have been the tallest structure man had built, and it set a pattern that was followed for thousands of years afterwards. Yet it had taken a mere 10 years for the Egyptians to graduate from wood and mud to stone. Its success is due to the genius in charge of the project. His name was Imhotep, and his influence on the times as important as Newton's to his. Imhotep's masterstroke was to harness the power of the stones themselves, and he did it by juxtaposing them. This is crucial inside the pyramid, where supporting walls hold the inner stones firmly in place. It's thanks to this discovery that the pyramids are still standing today. Imhotep was ambitious. His dream was to build a stone tower that would reach into the heavens. So from the desert rose a pyramid, step by step, 6 in all. Millions of tons of stone. Moving them, lifting them, fixing them all in place must have presented formidable difficulties. Even as the dream was finding its fulfillment, the tribes of Egypt were growing towards statehood, and the pyramid must have been a great inspiration to a people in search of a nation. The spiritual uplift of giving birth to a nation is something which is today beyond our imagination. And the concept which they established, that of the nation, is something beyond which man has not ventured. The climax of all that effort is a pyramid that towers over everything. The impression it makes owes a lot to the angle of incline, 51 degrees, 52 minutes. A far cry from the limits adopted immediately after Medum. In overcoming a physical barrier, the Egyptians overcame psychological limits too. The result is overwhelming, even by today's standards. Colossal, weighty, the embodiment of all the Egyptians believed in, all they dreamed of. Millions of stones, each one of them a permanent reminder of the individuals who labored over them, playing their part in the confirmation of those beliefs, the realization of those dreams. Each stone a reminder, too, that the pyramids exist not as a result of divine intervention, nor even of regal command. They're inspired, certainly, but of that inspiration that comes to the ordinary man as much as to his idols. Originally conceived to house the remains of kings, the pyramids stand today as epitaphs to the ordinary men who built them. The pyramids were built to house the mummified bodies of the pharaohs and their various treasures. A complicated maze of corridors and chambers was devised to keep their whereabouts secret. In the Great Pyramid, there's a descending passage. It leads from the entrance to a depth of 105 meters. A present-day comparison would find us 10 stories below ground. At the end of it, there's nothing but an empty chamber. Though it's claimed this was a decoy, it seems this original plan was changed to place the king's chamber more centrally. An ascending passage leads to a high-ceilinged corridor known as the Grand Gallery. We're looking up at it from below. It's 8 meters high and 47 meters long, and at the end of it, there's the king's chamber. Al-Mahmoud discovered it in the 9th century, but to his dismay, he found the coffin was already empty. Even today, there are many who think this is a false chamber, and that somewhere within the pyramid, the genuine one lies untouched, along with the gold and silver and the mummified body of the pharaoh. In 1765, in an attempt to locate the true chamber, Nathaniel Davison discovered another chamber above that of the king. He came upon it by accident. While measuring the chamber, he noticed a curious echo in one corner of the Grand Gallery and discovered an opening. It's through that opening that we're now making our way. It's about a meter wide, and the walls are encrusted with bat droppings. This is the first time that television cameras have been allowed inside, and there's a definite feeling of excitement as we approach the narrow space above the king's chamber. The Wellington Chamber. It's really little more than a gap in the stonework. In fact, it's one of 5 that are placed, one above the other, over the king's chamber. The purpose is to distribute the weight of the pyramid itself, and it's quite ingenious. Without this arrangement, the king's chamber would have collapsed. You can see that the pressure on the stones is considerable. These cracks have appeared slowly over the years, and it's not difficult to imagine what would have happened if the Egyptians hadn't incorporated the 5 small chambers. It's easy, too, to get caught up in the atmosphere, the mood of mystery. All the classic ingredients are here. But our pursuit is more along the lines of history and science, and at around the halfway point, about 70 meters up, there's something that links both. This red line extends back some 4,500 years. It was probably used to check that the stones were level, just as other marks made in the quarry showed which way up the stones were to be placed. Above the 5 chambers, the stones form a gable. 24 stones, each weighing 30 tons, each bearing a colossal weight. Here there are more marks, this time hieroglyphics. They read Khufu and 17 years. A general interpretation is that this point was reached in the 17th year of the pharaoh Khufu's reign. If that is indeed so, the symbols were left here almost 5,000 years ago. Impressive facts. Impressive, too, the spirit of those who made it possible. And what strikes you inside the pyramid is the very real sense that the spirit is still very much alive. A gable is a sophisticated piece of architecture, and we wondered how the Egyptians had managed to build it. In the pyramid we had built, we put to the test our theory that they'd used sand, following a method that finds echoes in many other cultures. Above our own king's chamber, we prepared a wooden ceiling. We spread out a blanket prepared with holes that were temporarily plugged. Next came a heap of sand and the 4 large stones that we hoped would form our gable. It's now a simple matter of unplugging the holes and allowing the sand to flow through. We were confident of the theory, but well aware of the dangers involved, especially for those of us inside the chamber. At first, the sand trickled through rather slowly, but soon it began to pour through the holes. Gradually, the stones inclined towards each other, forming the gable. The Egyptians were adept at making use of natural resources. They'd learned, often the hard way, to benefit from their environment, and given the unlimited amount of sand all around them, it seems likely they would have put it to good use. Still, that same sand would have been a problem when it came to moving across it those huge blocks of stone. Archaeologists have generally accepted the argument that the answer lay in the use of wooden sleepers to cut down on the friction. Again, at our own pyramid, we ran an experiment using palm trees and a 3-ton cube of stone. From the start, there were problems. The sleepers were more like blocks than aids. It took enormous energy to move the stone, and almost at once the wood and the ground beneath it began to break up. We concluded that the Egyptians would not have tolerated such inefficiency. They must have had another method. What if they'd found a way of paving a path to the pyramid? The pyramid site would have to be littered with chips from the stones used in building. The material was, of course, limestone. We think the Egyptians used it to make cement of the sort that's still used today. By crushing or grinding the limestone chips, the Egyptians would have the first essential ingredient. On the large scale necessary for their work, they probably used a beast of burden to turn a large stone mill. All that was needed then was sand, of which there was plenty, and water, which would come from the Nile. And there you have it, a perfectly fine cement. Ideal for paving the way to the pyramid. But it seems likely that the Egyptians went a stage further. This illustration depicts a figure pouring something from a jug onto the path in front of the sledge. We tried using oil and found our experimental blocks so much easier to move. We felt ourselves acting out a scene that must have been repeated countless times. Little seems to have changed, despite the centuries. The more we experienced the problems, the more our respect for the Egyptians seemed to grow. The moving of the stones is one of the major keys to understanding the pyramids, and one of the major debating points on the mysteries associated with them. We repeated our experiments a number of times. Of course, the Egyptians not only had to move their millions of stones to the site of the pyramid, they also had to lift them to the building level. And as we contemplated the enormity of that task, we wondered if they might have used a ramp. Imagine a 2-kilometer-long ramp 60 meters wide. 20 lanes, 100 sledges, 40 or 50 men per sledge, a total workforce of around 5,000. With a paved ramp and an orderly system, it's likely that the workers moved the stones more easily and faster, and who knows, perhaps more readily than we've been given to think. A mammoth undertaking, certainly, but well in keeping with the final goal, and no more unbelievable than the original vision. In fact, there is a straight causeway which leads up to the pyramid of Khafre. We believe this is what's left of the building ramp. Only the remains can be picked out today, overshadowed as they are by the Sphinx. But once it must have been a hive of activity, 100 million people, 2.7 million stones, a 30-year project, which calculated at today's values would have accounted for a cool 830 billion US dollars. Playing games with figures and calculations is part and parcel of exploring the pyramids. In recent years especially, a lot of attention's been paid to the almost magical equations that have been cited as evidence of their mystical nature. They are, some say, clues to a divine prophecy. They're creations of a higher intelligence, messages from another planet. And it's hard to see what else they could be when you consider the astonishing mathematics of Khufu's pyramid. A line drawn from north to south. The line is a mere 3 minutes and 6 seconds deviant from the celestial meridian, which means that the pyramid was built to face true north. If we take into account the annual aberration caused by the Earth's movement over the past 4,500 years, the deviation becomes an even more unbelievable 0.6 seconds. Again, checking the horizontal difference between the southwest and northwest angles, we discover it to be a mere 12.5 millimeters, accuracy of a degree associated with today's engineering. The measurements of the Great Pyramid offer still more intriguing patterns. Its base length is 230.364 meters. The circumference, 921.456 meters. Consider a circle with a radius equivalent to the pyramid's height. Identical. When John Taylor, the 19th century editor of the London Observer, hit on this coincidence, he remarked, "I was thunderstruck, developed a fever and was bedridden on the night," which has perhaps only encouraged others to go on looking for similar clues. Multiply the length of the side by 2 and divide the result by the height, and you come up with an even bigger surprise. 230.364 times 2 divided by 146.599 equals 3.14. Recognize it? Pi, the ratio of a circle's circumference to its diameter contained within the pyramid. This degree of accuracy is often quoted to support the theory that the pyramid is the depository of superior knowledge. John Taylor suggested the Egyptians were aware of the spherical nature of the Earth and had calculated its radius and circumference. They built this calculation pi into the pyramid to preserve the knowledge for later civilizations. So convinced was he that the pyramids held secret knowledge that Taylor spent the rest of his life studying them. He died insane and ignored. But it's easy to see why he was so obsessed. Even today, pi is used to only 2 decimals in vital calculations such as those for the NASA space projects. So how did the Egyptians know about it? One suggestion is that they were taught by extraterrestrial beings. Years ago, superior intelligences arrived in spacecraft and left behind them clues to their wealth of wisdom. We thought we'd check out the facts for ourselves. This time, instead of using our own pyramid, we measured the Great Pyramid itself. The most accurate method of making linear ground measurements is to use a steel measuring tape and a transit compass, in much the same way as a racetrack is officially measured. For stricter accuracy, the temperature is recorded, along with the force on the stretched tape, and the slight expansions or contractions are corrected in calculation. To be any more accurate, you'd need to employ laser beams. But could the Egyptians have approached this kind of accuracy? The answer must certainly be no if they used the sort of papyrus rope still found today in the Cairo Museum. If a steel tape can stretch, imagine what would happen with papyrus. In any case, measuring large distances with any form of yardstick compounds the errors. Given the Egyptian attention to detail, we felt there was another answer. We wondered too which came first, the height of the pyramid or the base length. The figures indicate that the height came first. The Great Pyramid stands 146.599 meters high, a cumbersome figure. But when it's converted into cubits, the ancient unit of measurement, it rounds out to a comfortable 280. Having worked out their projected height, how did they calculate the base? Indeed, how did they make their measurements at all? That was a question that left us at a loss for almost a month. We found our clue in a Japanese newspaper, in an article far removed from pyramids. It concerned a marathon event held in New Zealand where the first 12 runners had each broken world records. But a matter of days later, the records had been nullified. Suspicious officials had checked the mileage recorded by the police motorcycle that had preceded the runners, and they decided to remeasure the course. They found it short by more than 2,000 meters. The checks were done using 2 measuring wheels of different size. They measured the course at 42.195 kilometers, thus revealing the shortage. But the interesting thing to us was that over that large distance, the error between the 2 wheels was a mere 9 meters. Suppose the Egyptians had used a wheel to make their measurements. We decided on another experiment and used the only wheel we could find. A rope made sure we kept to a straight line, and at the foot of the Great Pyramid, we rolled the wheel along, keeping a close check on the number of revolutions, just as we suspect the Egyptians must have done. What at first might appear to be a rather haphazard method actually turns out to be quite accurate. The measuring wheels we use today are designed so that the circumference is a convenient unit. 1 revolution, for example, to 1 meter. The Egyptians, too, would have gone for convenience and probably used a wheel that had a diameter of 1 cubit. That converts to something like 52.35 centimeters. 1 revolution would therefore cover a distance of 1.6446 meters. We knew that to confirm our theory, we would have to divide the periphery of the pyramid by this unlikely figure. Not without trepidation, we put it to the test. The result was close enough to be convincing. Interesting that 140 is exactly half the figure given as the height of the pyramid, 280 cubits. We conclude then that the Egyptians first decided on the height and then used a wheel 1 cubit in diameter to mark out 70 revolutions in each direction from a central point. Drawing lines from these 2 points to the apex resulted in the 51-degree, 52-minutes angle which gives Khufu's pyramid its beautiful shape. There's one more thing which you may already have spotted. If the measurement was made using wheels, the figure for pi is bound to be included in the calculations, even if the Egyptians had never heard of it. Let's recap. Select a height, 2, and draw a circle with the radius 1. Turn the circle once in each direction. Connect the points. Simple. 2, 1, 1. That's all the mathematics the Egyptians needed. Let's recap. Select a height, 2, and draw a circle with the radius 1. Turn the circle once in each direction. Connect the points. Simple. 2, 1, 1. That's all the mathematics the Egyptians needed. They had no knowledge of pi, of global diameters, the circumference of the Earth, and we doubt that there was any guidance from another world. True, it's amusing to look for miracles, mystic messages and UFOs, but how much more rewarding to discover that the power that drives man on, that enables him to step into the future, is what he has within. A simple sum, 2, 1, 1. Straight lines, circles, angles, stone, sand, the waters of the Nile. These were all the Egyptians needed to build the pyramids. And of course, the vision, the enthusiasm, the sheer hard work. Our own pyramid took 2 months to build, and we needed a workforce of 15,000. 1.5 kilometers south of Giza, it shone in the sun, and we were proud of it. And yet we knew, for all the effort, our pyramid was nothing in comparison with the giants that loomed in the desert. In fact, our pyramid was only as large as the missing part of Khufu's pyramid.
Piramid の上から飛行機を飛ばすっていうのが東京から来る時からの金子カメラマンの夢でしたけど、これはノート破ってきたカメでしょ。
そうですよ。
よし。よし。よーい、人だ。人だー。
The science and technology with which we now live made it possible for us to explore the pyramids. But are our achievements, for all the computerized sophistication, really any better than those of the Egyptians with their simple arithmetic? Have we done as much as they did? Every day, hundreds of people gather close by the pyramids, symbols of a drive that thousands of years ago united men and gave birth to the concept of nationhood. Idea since then has forwarded that concept quite as much. Indeed, many ideas result in struggles between nations, between men. nationhood is too small for us now. Perhaps the time has come to take the next step, for the human race to aspire to something as grand and as awe-inspiring as the pyramids. Imagine all mankind united in the pursuit of a common goal, a worldwide undertaking in which men speak the same language and share the same ideas, desiring the same end. Only by working together in this way can mankind take the next great step forward. What shape will that step take? That is the mystery.